Welcome to Software Snack Bites. I'm your host, Shomik of Bold Start Ventures, where we partner with dev first and SaaS founders from the first line of code. Today, we're excited to have Muji on the pod. Muji is the founder and writer of Hhhypergrowth, which contains the best technical research that I've read on software companies and other companies outside of that too, but broadly software companies. We'll link to some popular posts in the show notes, but I highly recommend people to subscribe to Muji's service as I do. I'm about as deep as one can get in the infrastructure world, and I still subscribe. I'm an avid reader, and so I encourage you all to do so as well. So today we're going to cover a lot of surface area, particularly in infrastructure, data infrastructure, edge networks, SASE network security, and also just how Muji goes about doing the research into new companies and technologies. So welcome to the show, Muji.
Why, thanks, Shomik.
So let's dive in. We're going to start with data broadly and data infrastructure. And so you have a couple posts where you go into this in great depth, but I would like to just ask you to describe the high-level differences between Snowflake, Redshift, and BigQuery to start us off.
Yeah, sure. Those are all major competitors in cloud data warehouses that kind of emerged with AWS and Redshift, which is basically a glorified Postgres database that is tuned for analytical capabilities. And then BigQuery emerged and really changed that model from hosted clusters of a data warehouse into a serverless model. And Snowflake emerged out of that train of thought where they wanted to go serverless in that you didn't have to worry about the underlying infrastructure, set up specific cluster sizes and that sort of thing, or they greatly dumbed it down. But they really focused on the separation of storage and compute, which is a paradigm that emerged out of Hadoop and big data to greatly be able to scale up those two factors independently, and really did it in a turnkey fashion. So they're aiming to be a much simpler platform where you don't have to go in with a lot of expertise, have really very few knobs that you can turn to adjust the performance. You pick some simple t-shirt sizes for what size of cluster you want, small, medium, and large, and you can really hone those clusters around the same pool of data in Snowflake based on individual work cases and departments and such. So you can have one cluster dedicated to all the ingest and all the data engineering, data manipulation as data flows into the data warehouse, and you can have another for all the business analytics going on, another one for data science use. That's really what companies have the option here is no infrastructural concerns whatsoever, but they can really hone their usage and focus on that kind of price to performance combination in Snowflake really easily. And so I think they had a benefit over where a lot of the hyperscalers were going with Redshift and BigQuery. However, I'd say that those hyperscalers are catching up to some of the unique features of Snowflake.
And that was going to be my question. So the separation of storage and compute, it helps explain maybe the initial breakout of Snowflake, right? But the hyperscalers aren't stupid. But still, Snowflake continues to gain more and more adoption and continue to expand. And so what in your mind is the reason for that? Like, I don't think it's as simple, and maybe you think it is, but like, I don't think it's just the multi-cloud story, right? I don't think it's like, hey, we span across all clouds or something, but maybe that's how you view it. I'm just curious, like, what do you think still keeps Snowflake moving so fast ahead of, some of those other competitors?
Yeah, certainly multi-cloud plays into it. They're cloud neutral essentially in that they have regions across clouds. They can span across clouds, across regions, so that I can have one department using Azure in Europe and another using AWS in the United States. And that data can seamlessly migrate between the two to keep them both in sync. So they, again, have really kind of dumbed down the infrastructure. That's actually quite complicated in the world of databases. Distributed data and how you distribute data and keep things in sync is difficult and needs to be constantly managed and monitored. That, again, is greatly simplified in their turnkey platform. That's part of their uniqueness. Again, they had the separation of storage and compute. BigQuery's always had that, but the others are catching up to that. They've moved from data warehousing into other use cases like supporting data science. So they have been one to adopt the move into data lakes and data lake houses, which is the combination of these kind of raw data pools in data lakes, as well as organized organizational data in data warehouses. They were fairly early to that as well. That's where Databricks is really coming up against them. But Google, Azure, all moving in that same direction towards data lakehouses. They have a unique capability. I still see it as fairly unique in how they allow sharing of data and pools of shared data between organizations that are in some kind of partnership or collective of data. All parties can be contributing data to the same pool and sharing data across it. Other hyperscalers are catching up on that regard, now allowing better sharing of data sets. It's not just data sharing, but it's a marketplace of data so that you can have data brokers there using their data in a live way to enhance your data sets. You're not importing that data into your database. You're able to live query it. And so that's, again, started as a differentiator, is starting to erode. They're moving on beyond that into native applications that you embed into your database directly, which is a whole new app deployment paradigm that hasn't really existed yet. Thus far, you can put your data set wherever the compute is going to be. They are allowing that compute to occur directly in the database. That's really shifting to this, where this is going. They like to say it's bringing your apps to the data instead of your data to the apps, and is really allowing them to be that centralized store of data, really the system of record for all this operational data. Regardless of where it's generated and lives, it's all going to eventually flow into Snowflake, and then you're going to have apps within that. It's kind of becoming its own form of cloud, which they call the data cloud. So they still have a uniqueness here, but clearly others are still paying attention. Just today, Databricks announced Lakehouse apps. So it's following them that native embedded application paradigm as well. So Snowflake is leading in a lot of directions. All the competition tends to catch up pretty quickly.
For a developer that's listening to this, though, and is saying, hey, that sounds pretty cool, native apps, what would the benefits to them be described as? I mean, obviously there's a latency benefit to having the app be so near the data, right? But are there other benefits that you would say, hey, this could really improve upon the existing architectures that people are building apps upon?
Yes, in that you don't have to maintain any infrastructure whatsoever. I'd actually flip it and say the bigger benefits are to the customer themselves, in that the data never has to leave their hands. They maintain complete control of their data. It's entirely within their control in their own Snowflake cluster and never actually departs them. So you've got managed services that exist now that you have to completely upload your data into. So it's completely outside of your control at that point. That's been shifting to what Snowflake likes to call connected apps, which is you provide them credentials and they can log into your database and be making queries directly in your database, but they still have some external service that has to be hosted somewhere. So the evolution of all those is into this native apps, or what I like to think of as embedded apps within the database itself, that live entirely in the customer's control. The data within the database never goes anywhere else. So this is especially appealing in regulated industries, or just, this is all fairly sensitive data for all these companies about how much sales you made and how your operations work. You don't want that data to leak. And so I see this as driving a whole new wave of compute from here, in that not compute about the applications running. So far, that's going to be free, actually. It's the queries that those applications generate that is of value to Snowflake.
That's a very interesting way to think about it, and one that I will have to go back and spend some more time on, because that customer value prop is pretty impressive.
I think that's more important than the developer side. Yes, the developer doesn't have to maintain their own infrastructure. That is appealing. You can have apps that embed directly into the customer's database. I like almost equate this to what Oracle used to do. They'd create this platform that you'd have to install locally, but then they controlled the applications that would be installed into that platform, and it had to come from Oracle. It's like that, but way more beneficial to the customer, in that the customer maintains the control of the data. They exactly carve out what that embedded app can do within their database, meaning the rows and columns of a specific table or two that it can utilize. But they could be using these embedded apps to really do a lot of enrichment, data transformation. I think the new wave of AI and ML features coming just this summit, Snowflake Summit that's occurring next week, there's going to be risk scoring, fraud detection. These are going to be installable as native apps directly into your database at this point.
Very cool. Well, one question I wanted to ask you is actually about OLAP versus OLTP. And so online analytical processing versus online transaction processing. And transaction processing for a long time has been the databases that we all know and love and have heard about and have dominated the ecosystem for quite a long time, right? Now, it seems like that story has almost flipped. And it's much more the OLAP side that's getting all the attention and getting all the noise. And so, why do you think that shift has occurred? Why is OLAP now the faster growing market?
I always have an avoidance of the giant acronyms if I can help it. Those are ones I tend to avoid. I like to consider them as the operational databases are the transactional ones. And the analytical databases are the ones that are collecting data out of those operational databases and pooling it all together into one place for you to manage the entirety of your global operations. And so operational versus analytical is the way I like to separate those two. Absolutely, analytical has risen in that what used to be a data warehouse, you'd have to buy some incredibly beefy server to host this on. And even then, it would have to churn for hours and hours and even days on certain analytical problems as it crunched all your historical data to come up with this month's reports. That has really morphed into this paradigm of the modern data stack. You've talked about it on your podcast before, where the data warehouse is transforming in purpose. It's not just for data warehousing now in the operational view. It can be used for data operations themselves, engineering use cases, the transformation and collection of data. It can be used for data science, where you're trying to extract meaning out of raw data and even unstructured data, such as video files and audio files, images, that sort of thing. And use cases beyond that now that are really opening up with AI features. And so it's changing the purpose of what the store of data really means to a company. But beyond that, the modern data stack is being built with the data warehouse, let's just call it more broadly the data lakehouse, as a big pool of data that a lot of different tools and departments and use cases all interconnect to. And so now you have sales organization tools that can better leverage that data within that platform. You have marketing campaigns that can derive out of that sales data and know how to segment your customers into cohorts and know how to message them. And so you're really using that underlying data to not just look at it and try to make human-driven decisions about where your business needs to go, but it's really driving the business at this point. And so it's the importance of that now becoming kind of the beating heart of business, in that your business needs to be data-driven. You need to know your inventory levels, your supply chain, demand, and how it's shifting on a real-time basis. And you can't rely on, I got to collect all these data from 50 different platforms we use, take the time to move all that data somewhere else and organize it. You really need to streamline that process to be as real-time as possible. And so I see the value of BigQuery and Snowflake and Databricks' Delta Lakehouse in being that beating heart for modern global enterprises.
Yeah. When I told Twitter that you were going to be on the podcast, of course, everybody was curious to know more about your thoughts on Snowflake and Databricks. And so I want to ask a specific question on that, which is basically, so Snowflake has released their Python workflows and Snowpark, is that what it's called? I believe.
Snowpark, yep.
They've released that. They're trying to move deeper, like you said, into data scientist workflows. Meanwhile, Databricks has lived and breathed that from day zero, right? And that's where they've grown up with kind of Spark and much deeper Python support. And so with these LLMs pushing things forward, right? who almost has, I say, more of the edge in terms of those AI workloads, right? Do you think Snowpark and Snowflake has covered enough surface area to be able to start to take those on, or is it still mostly going to be on the Databricks side?
I see it as both being appropriate. Absolutely, this is where Databricks emerged, is Spark from the Hadoop ecosystem that really won Hadoop and is really the one lasting feature out of Hadoop that remains today is Spark, which is in-memory data processing over vast quantities of data via programmable notebooks. And so it's fantastic for data exploration, data manipulation, and analysis, and ultimately data science and driving machine learning jobs. That is what Databricks lives and breathes. And so they're, of course, highly ideal tool for this moment in time if you have a data department, if you have a data science department, I should say. So if you are running your own models, you're creating your own models, it's a great platform for that. That is what Snowflake has been trying to move towards over time. They've long said that they've had data science use cases, but it really was unlocked with Snowpark, which is their answer for Spark embedded within the Snowflake platform. So you can run Spark jobs and you convert Snowpark into Spark jobs and run it directly on the database. So this is Snowflake moving towards Databricks. Databricks at the same time has been moving towards Snowflake by creating a whole new open source Delta Lake, added Delta sharing and data governance on top of it. And so they've been moving towards that same long-term goal to collide. Absolutely. We'll have to see how well Snowpark does. They certainly claim that it is highly performant, but really that depends on where you're running Spark. And I think a lot of it benefits from running Spark directly adjacent to the data. You're not piping that data to some other process in AWS and Azure, wherever you're hosting that Snowflake database, to then process that data further. It's all right there. You have so much less data movement. That is a huge part of that performance gain. Like they did with data warehousing, I think they're trying for a simpler platform. So it's really, do you have the expertise to use these kind of do-it-yourself components, manage these things yourself in a open source Delta Lake, but then use Databricks' proprietary engine on top of it and platform, or they can, they're going to be moving into managing it for you as well and move into more turnkey services, of course, from here. But it's, do you have the resources to run all that yourself, or do you want a turnkey platform to do it for you in Snowflake? So that, for me, is the big difference between those platforms. Of course, this is also where Azure is moving with its new data lakehouse called Fabric. It's where Google has been moving with its Big Lake and BigQuery, and how well it's integrating Spark deeply into its own platform, kind of circumventing the need for Databricks, who happen to be a partner of theirs as well. So, there's a lot of friend and enemy movements within the same companies. And so it's been pretty fascinating to watch it all play out, but they're all moving to a very similar place, which is pools of data that you can share with other people in a secure and governed way that can be used with other tools and really power that modern data stack.
When we do this again, let's say next year, I imagine all of what we just talked about will have shifted in multiple different ways.
Every 3 months, there's some major news from one of them. And really, at this point, it's what's Snowflake going to do next at this summit? Databricks is hot on their heels and ahead of them in many ways. The others are catching up, but moving much more slowly and are behind Databricks and Snowflake. We've covered the 5 major competitors in there.
Yeah. We talked a lot about data, and in that we talked about latency and data sovereignty, right, in terms of customers owning their data. And so one of the interesting areas that I wanted to move into is actually edge networks, which I think play into a lot of those trends. And so first, broad question for the audience that may not be aware, can you describe what edge networks are and how they literally have these point of presences, these POPs, all over the world?
Sure. I'd like to compare it first to the traditional hyperscaler cloud, which is all about centralization of resources. AWS started, put a bunch of boxes all in one place, and you can go rent compute and space on those boxes. Then they started putting those in different regions and split those regions into different availability zones so that you can assure that, yes, I'm in this London region, but if that data center goes down, I want to make sure my software all stays up.
Although for some reason, US East 1 still seems to be the one that when it goes down, the whole world breaks. But
there's heavy ones for sure. So I almost call that the hub and spoke model of cloud, in that the hub is these regional centers, but then they split out and have availability zones and even local zones in a particular city, in AWS's case. And so that's the centralized cloud. What an edge network is attempting to do is create a giant global network where there's compute available at these points of presence, POPs, or POPs, that have the compute in them and then control all the networking in between them. So I like to equate it to a giant mesh network across the globe. So instead of centralized compute having a lot of compute power in one place, they've taken up compute, split it all up into 200, 300, 400 different locations. And the benefit there is you've got compute everywhere. I like to call these the everywhere clouds, in that in this world of distributed users, distributed applications, edge networks are ideal at interconnecting those. So regardless of where a user is across the globe, they can enter an edge network and then be routed efficiently across the globe to wherever the application is or wherever they're going on the network. And so the value I saw in edge networks pretty clearly is that once you've got compute power there, you can layer on development capabilities to leverage that compute, have your customers and developers leverage that compute. The big difference there is when you deploy an application into a hyperscaler, you're deploying it to some specific piece of infrastructure that you've rented. So I'm deploying to US East 1 to a VM that I created or a container I'm deploying there. With an edge network, you're deploying it to all POPs at once. So your application lives everywhere. So it's fantastic for globally distributed applications. Data sovereignty, you were just mentioning, you can corral the network that any particular application uses to a particular region like Europe, keep data local to you, regardless of where you are on the globe. So it's a completely different paradigm than traditional cloud.
That lays a great framework. And so then now the trend, as you were saying, that, hey, you can start to put development tools on top of that. And so Cloudflare has come out with Workers and Fastly has Compute at Edge.
Yes.
So why are you so excited about those products now being layered on top of these edge networks?
Well, what I think it gives these companies, if they have the resources to do it, is optionality, in that you've got a giant programmable network. I like to think of the POPs not as nodes where the compute lives. I like to think of them as gateways in and out of that global network. So I, as a user in North Carolina, am making a request. I'm going to enter the network through whatever the nearest POP is to me, let's say Atlanta or DC. I enter this private network. I get efficiently routed to wherever I need to go. So if I'm going to a server in Hong Kong, I'm going to route through their network from that point forward in a secure private network to wherever is nearest to the application where I'm going. Now, that's where I like the potential here, is that the optionality that gives, in that these companies can start pivoting towards security products. With Cloudflare, they were already very security focused over application stacks. Now that can be down to the individual networking requests going on. Much less than they can build on application development environments on top of it. So developers can take advantage of that compute as well as themselves. They are building these tools on their own application developer network. They're dogfooding their own product in order to build their next wave of products. And so I really like that architecture.
Yeah.
And so did the market there for 2021. Loved everything, but loved edge networks. And of course, there's a lot of jubilation about the potential of these, but it's finding the profits then of all these product lines that's now the challenge.
You know, AWS is CloudFront, right? So why is it that AWS, GCP, Azure, anybody, they already have these regions set up all over the world, right? And then it's not like Cloudflare is using Equinix and, whatever, all the other data center REITs and providers that are out there for their POPs, right? So like, what are we missing? Like, why can't AWS just go and do the same exact thing and just be like, hey, we've created this same edge network, just like you get with Cloudflare for any developer to use?
Actually, any company can build this themselves. Any company can go populate their own data centers, rent space from Equinix or whoever around the globe, and find some way to interconnect them. Twilio has done this on AWS proper for distribution of messaging. And so it's possible to build this yourself. They've already done this. I didn't really get into the history of how edge networks emerged, but it was out of the CDN and DDoS protection markets, but especially CDN, which is content delivery networks. The New York Times, published an article. I want to distribute that to these caches around the globe so that people don't have to traverse the globe back to my one server and display that page every time they ask for this article. And so you're distributing your content around the globe to greatly improve the speeds and responsiveness of your applications. That's where edge networks got architected, but really that's one use case. That optionality I was talking about, they can move in a bunch of different directions. Now, why AWS hasn't moved this way yet, I'm not quite sure. They have CloudFront, which is their CDN product, their content delivery network. They have Lambda at Edge, which is them moving Lambda, their serverless functions, towards CloudFront. And it's really built around CloudFront so that you can make CloudFront more programmable, which is where Fastly is really going with their compute platform as well. So it's to make content delivery more programmable, which is highly appealing to fast-moving modern web companies. With Cloudflare, I feel like they've got that security mindset to really take this into all new directions of where else edge networks come in handy. So there's this explosion of interest in AI and ML. That requires intense amounts of compute, massive amounts of data. That may not be ideal to run on an edge network. What is great to run on an edge network is data collection platforms, globally distributed applications, data messaging, where you've got to send data constantly between different parts of the globe, IoT platforms. And so I see it as a modern set of tools for today's developers for a particular direction of applications. Now, they're starting to move into deploying AI at the edge. It's still got to be really small models. You're not going to be deploying LLMs and generative AI at the edge just yet, although you're starting to deploy those things on device, on your Apple devices with their customized chips. But the way I like to think about the potential for edge networks is they're a smart network that can make dumb devices smarter. Think cameras, think point of sale systems, think temperature sensors, fleet tracking, GPS sensors. All that data can be being collected through this edge network and routed somewhere to make use of. And so I see that as being of a lot of value. I know this is a day and age where AI seems to generate the all the interest and dwarf everything else. But there's a lot of potential in data being unlocked with AI that I still see a lot of investment opportunities in.
AI has certainly taken the zeitgeist. I'm looking forward to a day when my Nest thermostat actually is more valuable than just the app that I can use on my phone, which, by the way, is very cool and I like it, but certainly feels like there could be a lot more stuff to be done there. But one final question actually I have on edge networks only before we actually move to more of the security side is actually more on, again, we've been talking about data. So what data looks like in sort of an edge network world. And so I guess my question is, do you still see people sending stuff back to data warehouses from these edge apps, right? Or do they have some sort of like local DB, like a SQLite type thing that nests alongside each of those applications at whatever edge point they're being interacted with? And then there's some sort of central parts that still get sent back to the data warehouse. I'm not sure if I'm describing it correctly, but do you have some sort of thoughts on how that might change things?
I actually think it's all of the above. You can have your database architected to have a database at the edge that is collecting data from various sources very near that edge point, that particular POP. But absolutely, the edge network is most primed for you to not be doing the most heavy compute at the edge. You absolutely can be doing compute, but the heaviest compute is going to be done elsewhere. So it serves as a routing device to those other places where it can ultimately serve as the master source for all the data globally, and you're going to be training AI over it or doing analytical processes over the entirety of the data in one place. But you can absolutely have the data stored at the individual POPs and be doing analytics on them, say for fleet tracking or IoT analysis directly in that POP. And so all of the above, really. It's ideal for both of those, or they're starting to develop products around both of those use cases, Cloudflare in particular. And I see both of them being highly valuable. Much less stream processing and where Confluent's been trying to go lately with Apache Flink. There's value in real-time data and data in motion. And I think edge networks are primed for that as well.
Got it. So it almost might be people choosing what is specialized for the task that they're looking for, but still it's not necessarily changing the existing paradigm. It's just adding some other things to it that they could start to use. So
yeah, it's providing the networking. Yeah. You don't have to build this highly distributed network of collection points yourself. You can leverage this as a whole new type of cloud.
Yeah. Well, you were one of the first people who got me thinking about SASE networks. And I'm very curious as to how you saw this coming, because you were one of the first people I saw publicly getting very excited about, before even Cloudflare was really even announcing stuff, just saying, hey, this is just amazing for Cloudflare to be able to leverage this. And you had this idea where, hey, networking and security are going to be very closely tied together. What drove you to that conclusion? How did you see the world playing there before it kind of came onto that stage? What were you seeing that got you excited about the convergence of those two things?
Security I've always been hesitant to invest in because it is constantly evolving. The adversaries typically are one step ahead, and it just takes one massive breach or really lacks attitudes towards security of their own internal product that can really make or break investments in that space. There's always kind of the next disruption to come along. I think zero trust was pretty easily identifiable as being a major wave. Now, it's somewhat of a nebulous term, but you're basically really tightly, granularly controlling access to individual users and individual applications. What enables that is the network in between them. So you could always do this with firewalls and patching things together. It would have been 10 times the work to do it over just kind of the castle and moat traditional security. And so that's really what's improved, is that this has kind of always been possible, but you never really had a platform that could oversee all your users, all your applications, and be that middle layer between them, the interconnectivity and the switchboard, as Zscaler likes to call themselves. And so I saw the potential with Zero Trust, with Zscaler, and then with Cloudflare, with that edge network. Again, because they're the interconnection point between a lot of distributed users and a lot of distributed applications, way back since their founding, they were a middle layer for app services and security. They honed that into a zero trust and secure web gateway product. Zero trust is providing you a private access to your own internal applications in a very granular way, so that someone doesn't have to VPN into your network. They provide a layer where a user can directly access an application, never being on your network directly. And then Secure Web Gateway is a layer where all your web usage for enterprise tools goes through a Secure Web Gateway, typically done in the past with an appliance that you would install into your network, and you'd route all your traffic through a data center, then to the public internet. So it's been around a long time, that the concept of a Secure Web Gateway. It took the cloud to really realize the potential that, I don't have to send all my bandwidth to one place as a choke point. I can have this cloud service be that middle layer and interconnect my users with Microsoft Office, with Zoom, with Workday, the tools that they use in a very secure and governed way. And so you had these platforms starting to emerge. That ultimately got branded as SASE by Gartner, which is Secure Access Service Edge. a total mouthful.
Just horrible.
Not the most ideal
horrible
acronym. And it actually kind of got worse from there. They split it in half. But before I get to that point, they took where I was going with zero trust and secure web gateways, which is the user access security, and combined it with networking security about how you interconnect your various locations. How do I interconnect my headquarters to my data center, to my remote branches, to my cloud environments? It creates a private, secure network across all those things, plus zero trust, plus a secure web gateway, plus CASB, which is governed access of your enterprise tools and preventing you from using ones that aren't sanctioned. And so you've got all these tools emerging that Gartner branded as SASE. They decided to split it in half and say, oh, well, there's the SD-WAN portion of the inner networking, and then there's the SSE part, Secure Service Edge, which they just lost the A, access, which was actually all about what zero trust is all about. Some reason lost the A and called it SSE. So now the branding is SSE or SASE to mean, zero trust secure web gateway. If it's full SASE, it means the entire networking suite of SD-WAN kind of capabilities, or it interworks with SD-WAN partners to interconnect branches and headquarters and such. So you've got the user access part in zero trust, and then the networking part in SD-WAN.
Yeah.
All together in one platform that typically spans the globe. Again, why edge networks are so ideally suited in that your users can be anywhere, your apps can be anywhere, your cloud environments, your retail locations, your factories, whatnot. SASE platform serves as the interconnection of all those points globally.
But I want to dive deeper into Cloudflare specifically, because why did you think they were so well positioned versus, obviously, I think actually you were at one point, and maybe still are, long Zscaler, and you've studied Netscope and Cato and all the other players out there, right? But from the beginning, you were very excited about Cloudflare moving into this world. And you were one of the few people that was very excited about it and just pounding the table for this makes a lot of sense. So what was that? Why specifically Cloudflare versus Zscaler, Netscope, some of the others?
Well, specifically for Cloudflare is the optionality. So enterprise security of user access. These are my users. These are the apps they're doing, either private apps or SaaS apps that exist out in the world, or they're interconnecting to clouds, or it was just ideally architected through their years and years of being a CDN, and DDoS protection was ideally architected for a SASE network. And in fact, Gartner has said in some of their reviews and market guides that an edge network-based platform is the best architecture for this because of their distributed POPs and because of how they can segment traffic and provide other things like smart routing around problematic areas of the internet, etc. And so Cloudflare was very ideally situated from how it had architected itself, but it was very nascent to this market. It was brand new in January 2020 when I was discovering the company, right before COVID hit. And then, of course, everything kind of went out the window with work from home over the next year plus and drove all that excitement in SASE networks. Definitely got ahead of itself because even Gartner's own recommendations and, Gartner and Forrester, the industry minders, have been all over this as a trend of SASE networks and zero trust. And now SSE, or what Gartner calls it. I just like to call it all zero trust. But it's slowly being adopted as the next generation of network security. You're leaving that world behind of castle and moat because you cannot draw a moat around my headquarters and retail locations across the United States and a cloud environment over here in this region. And then, oh, wait, in Europe, we just acquired someone and now have to draw it around Azure, even though we use AWS over here. And you just can't draw these boundaries. And then the workforce entirely went remote. You can't draw a boundary around that. You've suddenly got home offices times 5,000 instead of one headquarters. And so it just made clear sense to me that it was the next generation, the coming wave of what network security was going to mean. Not these kind of point-to-point solutions, not firewalls around everything, VPNing into your office in order to even use the internet tools that the office uses. And so it's really enabled by the cloud. And then I feel like edge networks are very uniquely situated to provide this kind of capability. Of course, going up against huge names like Zscaler that defined this category for the most part, or at least with Zero Trust and Secure Web Gateway cloud natively. And now Palo Alto obviously has been hugely risen into this direction, and it is the primary focus for them, which is interesting in that it eats their other market. But they've found a way to navigate it where it's not so much eating their market, that they leverage their existing pool of firewalls that they sell out into the world that you're installing not only on premise and branches, but also in the cloud. They're virtual firewalls that you install on a VM or a container into the cloud environments. They're providing a massive managed service over those that interconnect them all into a rough platform. But that's remarkably for them has proven a great strategy, because then they can still sell all the firewalls and a SASE service on top of it.
The fact that they can still lead with firewalls is just remarkable to me. Just, it doesn't seem to have slowed down at all. And that would not have been what I would have expected going in.
The threat environment continually gets worse and worse. It's so hard from a firewall perspective to maintain security, to know who to grant access moving into your environment, and even those inside going out of your environment. They have navigated it extremely well. When I thought Palo Alto was becoming a Frankenstein of acquisitions over the 3-year period, and then I thought because this was being served by cloud platforms that firewalls would kind of become a relic, that you did need individual connection from any point into the cloud platform or edge platform. But as I said, somehow Palo Alto has really walked the line quite impressively. But the traditional model of security and the new one, and actually I think in retrospect, I did not give Palo Alto much credit and was not that interested in them as a company because of what was emerging in Zscaler, Cloudflare, Netscope, etc. So kudos to them for navigating that. I think what ultimately happened is the reticence of IT organizations to give up something out of their control. They're so used to buying a bunch of appliances. Once they had those things in place and configured and stuff, it was all under their control. Now it's a total nightmare because you have to maintain it continuously. You have to patch things every other day, it feels like. Constantly monitor things, so many false positives. And it's just, network security is extremely difficult to manage on an ongoing daily basis. So I thought turnkey and better solutions would preclude that. But I think IT departments are like, nope, we know this method of security that's all firewall based. And Palo Alto played that transition from traditional to next gen quite well.
They made some very impressive acquisitions. I got to hand it to them on the M&A front. Just amazing companies. I still don't think they're fully tied together in the way that you would expect or want them to be. But at the same time, it reminds me of, in a way, Salesforce with their apps. Like sometimes distribution, just great distribution can win. And with their Prisma and Cortex suites of products, they've been able to leverage their distribution. And like you said, they're toehold already into the IT orgs to expand from there. It's been remarkable.
It is. And that, if I was an investor in Palo Alto, it's entirely about their next gen security, which they call NGS, which is Prisma SASE, which is them taking what was their VPN and making it into a platform that oversees managed firewalls. So, you still have all those 200 firewalls across your organization, but it's a platform that oversees them all for SASE access. And then Prisma Cloud, which I am the most impressed with. They bought a couple of companies that allowed them to move into cloud security very quickly, which is container security, serverless security, SIEMs, which are analyzing the identity and entitlements within cloud environments, who has access to what. And so they moved really quickly due to those acquisitions and put some together that what Gartner likes to call the CNAPP side of things, Cloud Native Application Protection Platforms. Again, a mouthful. Let's just call it cloud security in Prisma Cloud. And then Cortex, which is their XDR or EDR endpoint protection platform that's moving into XDR, as well as automation capabilities and external attack surface management side of things. So which is the world of CrowdStrike and SentinelOne, let's say. So they're competing with Zscaler in one front, Cloudflare in another, CrowdStrike, SentinelOne, all these other security players are in some way represented in that NGS triumvirate of three different product lines. I think their cloud security is incredibly impressive, but they're all in on this SASE. That they were firewall first for sales. They're switching to SASE first at this point through firewalls, but they're really helping customers make that transition from older traditional network security to new. And that's where they're excelling. Their XDR side of things is their weakest product, but is the endpoint protection, which is an agent that runs on your devices and laptops and servers, but it really fills out the product line.
The last question I have in the security topic actually is around those XDR players. So CrowdStrike, SentinelOne, they have a lot of zero trust capabilities that they've been rolling out. And I believe they've appeared on some SASE network, if not all of them, Gartner quadrants and Forrester waves and whatever. So how do you rate their ability to move into this when they don't have those sort of distributed application edge network sort of scenario or the private access type stuff that Zscaler has built out over time?
Palo Alto, I just mentioned the three segments of NGS: Prisma SASE, Prisma Cloud, Cortex XDR. Microsoft, I'd actually throw in the same, in that Microsoft is less SASE, but is moving into cloud security, XDR. They've got a SIM, which is log management and security analytics, kind of a data warehouse for security. And so you've got a lot of really big players covering a lot of bases. Zscaler is coming from zero trust, but moving into cloud security. CrowdStrike started at endpoint, is moving into cloud security. SentinelOne, the same, and have a partnership with Wiz to kind of fill out their missing gaps. So you've got different layers of competition with those platforms trying to be the all-in-one. And then it's crazy because you have partnerships between Zscaler and CrowdStrike, say, and Zscaler and SentinelOne, and Cloudflare is partners with both, that are starting to compete with them on certain fronts. Now, I wouldn't say CrowdStrike is SASE or SentinelOne. They're pretty dedicated to the endpoint, but they're a clear transition and market adjacency is cloud security. So they used to protect servers and laptops and devices. Now they can protect containers and cloud environments. That's a much more seamless direction for them to move than into SASE and the networking side of the stack. There's some lines drawn there around that for some of the endpoint providers, but yeah, Palo Alto's trying to do it all, I guess, as is Microsoft.
It's crazy. Well, what I'd love to shift into actually is the research that you do. So you do, and we'll link to the Snowflake piece. That's still probably the best piece that anybody has put out in the world ever on Snowflake. I'm going to give you credit for that, Muji. That was a magnum opus, right? And what does your research process look like? Like when you are starting to do research on a new company, where do you start?
Well, I should probably go into my history a little bit. As a software developer, in particular, a database developer for decades, for a wide variety of Fortune 500 to startup companies, mostly as a hired gun. I was a consultant. I worked on a wide variety of projects. I was doing big data before you could really call it that. I was doing IoT data collection before it was named that. And so I, was immersed in data, immersed in app development, somewhat Hadoop, somewhat security adjacent. And so did that for years, ultimately was a lead architect in designing these systems out of open source components. That engineering background was critical to my research collection because I'm so used to seeing what the capabilities are of this platform, figuring out, what's the extent of this platform, what are the adjacencies. So when I look at a tech company, I can understand what they do, but I feel like I have pretty good insight into where they're going to go next. And that's really what I cover in some of these pieces. When I research, it's a bit of a free-for-all. It's really about the research tool of where I'm keeping this. I have my own tool I use called Obsidian, which is a lot like Roam, if you're familiar. A lot of people use Notion. You've got these personalized wikis that you can have. I love this modern wave of research tools to really capture in all these things, collect a bunch of links. I keep running notes of everything. And it's really, for me, writing it down that really drives it in for me versus just reading. And so I like to think of my service as a collector of all this data and then honing it down into something useful and understandable for the non-technical investment folk out there. So it's looking at a lot of marketing materials, product announcements, the financials, obviously, to understand the mechanics of the business, and then customer conferences I also find quite handy.
It's interesting, though, because you do a blend of primary research where you go to those user conferences and you talk about, hey, I saw this customer talk about it, how they used it, so on and so forth. But then meanwhile, you'll also be like, I won't actually mention whatever company it was because I forget, but you'll sometimes mention like, you know what, the marketing materials of this company are really shitty. And so you're doing both. You're going primary research, but then you're also seem to be reading the materials put out by the company. And so why are you doing that? Like if you're already doing the primary research, right? Like why also look at the marketing materials? Because those are, usually fluff. Like what are you looking for? What are you trying to tease apart in that?
You never know where the nugget of info is going to come from. So to me, yes, the marketing is often a lot of fluff. I can directly name the company that I was critical of their marketing materials. I'm talking about Zscaler. Really overly technical on their marketing. Luckily, they have a new, relatively recent CMO and greatly improved that. Not so much in their investor slide deck, but everywhere else, much improved marketing. So kudos, Zscaler. But it's part of my magic, I guess, in my service is understanding the mechanics of the business. How do they price? What's the potential to scale? And ultimately the success of this investment. But also, I like to understand the architecture of what they've built and where it can go next to try to identify those market adjacencies that they can easily pivot into. And so that was the appeal of edge networks, for instance. Once I discovered what they had built for a different purpose, which is sitting between a user and an application in order to control content caching and denial of service attacks, is being pivoted into other things like now zero trust security and secure web gateways, an app development platform, etc. Understanding that underlying architecture, I think, helps me know where or how easy some of these adjacencies will be and where these companies are going. So it's the marketing materials is more just to understand the platform. I do like to dive into some of the white papers about architecture so I can understand the difference between, say, what Zscaler is calling SASE, what Palo Alto is calling SASE, and what Cloudflare is calling SASE are absolutely three different architectures. But because of how deep I investigated Cloudflare's platform, for instance, I could see where they could potentially take this and start, as the CEO likes to say, spinning out S-curves from there. As long as they can sell them, it's fantastic. They're a complete innovation machine. So unfortunately, I love this stuff from an engineering perspective. So it's so easy to go down a rabbit hole with any of this that you can watch, the founders on a podcast. You can watch 16 hours of customer conference videos. You do need an aperture to control and focus in on the most important parts, which is typically the keynote of the customer conferences. And what are they releasing in the product releases and the PR that they really want people to know about are typically where I need to focus most. But you just never know where little insights are going to come from. So
when you find a new technology that you're excited about, say it's OpenTelemetry, it's eBPF, it's WebAssembly, it's whatever, when do you get the sense that, oh, okay, let me dive into that? Is it because you're seeing it pop up in the marketing materials more often? Is it because you're hearing about it talked about more often on transcripts? Or is it just like, oh, this is really cool, like from an architecture perspective, let me go dive deep into this to figure it out?
Well, I'm just excited I know what all those things are. So there's been so many rise of so many fads technologically. AI, we're in the midst of it right now. It's so visible to so many people that the hype train is absolutely at the highest right now. It's interesting from an enterprise perspective. I think it's actually easier to find what's the most relevant technology versus the consumer side. It's so visible. People get so excited about 3D printing, about autonomous driving. Name your fad every year for the past 10 years. There's been one on the technological side. And right now it's AI. Don't get me wrong, extremely excited about AI. It's more when it has the profit potential that it becomes interesting to me. I'm absolutely a technologist and optimist at heart, but it's not my interest that's driving this. It's what are the companies doing with it? How is this going to make them perform better? Or how is this going to be able to spin them into an adjacent market?
That makes sense. Well, two final questions. These are both audience questions. So one is, how do you think Amazon and Google's lead in specialized chips play into the LLM future? And I think what they mean by that is Amazon and Google's built TensorFlow, Amazon acquired Annapurna Labs for their sort of stuff. Like, will they kind of be able to figure things out maybe while others are trying to use Nvidia chips and so on and so forth? Like, will they be able to figure things out maybe in a different way because of their sort of specialized expertise?
I want to know who's naming Amazon's specialized chips, because Trainium, really? Like Inferentia, they could have done better.
ChatGPT, maybe actually not, probably not ChatGPT.
It's all, and I love thinking about the hyperscalers. I don't invest in them, but it's important to know what they're getting into and where they compete with a lot of these platforms, whether it's Elastic, Mongo, Snowflake, Cloudflare, whoever. And so it is ultimately the heart of your question is Nvidia is dominant and will remain dominant for the near future and likely mid and long-term future at this point. And so certainly there's other chipsets out there that are emerging in GPUs, which are more, obviously, won't go into the entire history of GPUs, but absolutely way better suited for the matrix multiplication that is done at scale in training and inference of these AI models emerging. I think it was important for the hyperscalers to ultimately go this direction. And I think it was a humongous advantage for AWS, especially with its Graviton chip line in the compute side, where they're able to have a specialized chip that can eke out better price performance. And you see it with platforms like Snowflake that have fully adopted it over time, passing on massive savings to their customers because they can do 20, 30% faster compute when they flip a switch, basically. And so huge advantage to AWS on the general compute side of things. On the GPUs, I think they have to. They correctly saw how huge the potential is for AI. They've all been developing their own ML platforms and their own big data and data warehousing and data lake platforms and operational databases galore. That's really a huge focus besides application compute of all these platforms is data. And so I think they all correctly foresaw that there's only so many chips NVIDIA can make in a given year, even though they're fabulous, I should say. So I think it's a good move on all their part and absolutely gives them, if done properly, an advantage going forward. Does it give them an advantage right now? No, because everybody's going to be flocking to NVIDIA for these large language model training that's needed currently, and then the ongoing inference. And of course, it's hard to find GPU space. You've got to navigate around. There's companies that are starting to leverage their pools of data better, allow you to move data between platforms because you need flexibility at this point. There's so many different ways to play AI right now, much less the app layers being built top it all. So that's a whole separate 3-part podcast series, folks.
That's right. Well, the last question is pretty good because it specifically says, so it is, what area of infrastructure do you think has the most innovation in the next couple of years? The qualifier, though, is outside of AI stuff.
Oh, well, that's a really huge qualifier. 100% of the market's interest right now would be that qualifier. So that's harder. So certainly cloud infrastructure, still the cloud is only 30% or so of app stack environments at the moment, according to some of the industry minders. So there's still fairly early innings to early mid innings of the cloud and migrations of workloads to the cloud. So there's plenty to like in there. And that's the whole crux of my newsletter, is following data and analytics, observability, app development, edge networks, and the potential of all those things in there. So beyond AI, well, I guess that doesn't necessarily exclude data. AI is proving out the adage that data is the new oil. And so clearly that's been the entire investing premise in data platforms now that I've had, at least for years now, is that there's a lot of value in that data. It's just up to companies to figure out how to unlock it. And I think that's where AI can really be leveraged at this point, unlocking value, especially in unstructured data. There's a whole use case there, but much less organizational data. And so data infrastructure is critical. Despite the AI part, it's been critical for a number of years. Beyond that, I'd say there's this coming rise of autonomous driving, smart factories, smart distribution, logistics that's being empowered by IoT. There's certainly lots to be interested in that direction as well.
I also think the threat vectors and attack surfaces that are being exposed through all these things that you're talking about, autonomous driving and things like that, is going to be also a pretty fruitful area, whether that's next 3 years or whether that's next 5 years or whatever the time frame is. At some point, those are going to be new attack surfaces too. So luckily for us, we're going to still have some jobs exploring.
Oh, no shortage of things to discuss for sure.
But thank you, Muji, so much for we covered a wide swath of topics here. Again, I can't tell people enough to subscribe to the Hhhypergrowth service. The link will be here. It's also 3 H's, Hhhypergrowth, if you're trying to search for it. So definitely go and subscribe. But Muji, if people would like to get in touch with you, or if there's anything you would like to say about upcoming things, please put that out there for the audience to know.
Oh, sure. So it's my Hhhypergrowth service is all about tech investing and explaining what a lot of these companies do and talking about product announcements and earnings takes. I am going to start another newsletter that goes a little more general and starts talking about the hyperscalers a bit more and more big tech. So look for that soon, but you can find me on Twitter as @hhhypergrowth.com for more details. I have to say, thank you for having me on the podcast. I'm not sure Snack Bites is the appropriate name for this podcast. We've been talking at great length here, so but always a blast to talk about this stuff with you.
Well, it's great diving in with you too, and that's the fun part, right? It's because it's my podcast. It can be a snack bite that gets enlarged into an entree. So
it is a full course meal at this point.
But Muji, thanks so much. As always, love chatting with you about this. I think you have amazing views and can't wait to see what you write about next and also what things you get excited about next, because I think you are very good about looking on the forefront of what's to come. So thanks for all you do. And hopefully people please go and subscribe. It is awesome content and would highly encourage it.
Thanks, Shomik.